Distance formula. Our standard says that we want to use coordinates to compute perimeters of polygons and areas of triangles and rectangles using the distance formula. So this is another formula that is on your formula sheet, the distance formula. In addition, we will also need the formulas for the area of a triangle and a rectangle, as well as the perimeter of any polygon, which these you should actually remember from middle school or elementary school. All right, our first objective, before we move into working with the distance formula, we're going to first work with Pythagorean's theorem. So for objective 1, we're going to calculate the length of a line segment using Pythagorean's theorem. So go ahead and take a moment and write this down. Press play once you have it written down. Example 1a. We're going to find the distance between the 2 points. Okay, take a minute to write this down and then just sketch that line beside it. Okay, so here we actually have a vertical line, okay? The good thing with horizontal and vertical lines is you don't have to do anything to figure out how long they are or the distance between the 2 points. You simply have to count. So if we want to figure out how long this line segment is, we're simply going to count from this point to this point. So let's start. We got 1, 2, 3, 4, 5, 6, 7. So the length of this line segment is 7 units. Okay. All right, now you guys try this one. We want to find the distance between these 2 points. Okay, so again, in order to find the length of this line segment from this point to this point, we're just going to count. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of this line segment, or the distance between those 2 points, is 10 units. All right, now we're going to move into using Pythagorean's theorem. Example 1b, we're going to find the distance between the 2 points using Pythagorean's theorem. So go ahead and take a moment to write this down, and then we'll work through the example together. Okay, so in order to use Pythagorean's theorem, you need a triangle. More specifically, you need a right triangle. So all we have here is a diagonal line segment. Well, we can create a triangle with this diagonal line segment. So I'm simply going to start at this point and go down, and then start at this point and go right. And now we've created a triangle, with this being our right angle. Okay? Now we're going to use what we did in our first example, which is figure out the length of this vertical and horizontal line. Okay? So this is 1, 2, 3. And this is 1, 2, 3, 4, 5. Okay? So now that we have a right triangle, we have the length of the 2 legs, we can use Pythagorean's theorem to find out the length of this diagonal line segment, which is the hypotenuse of the right triangle. Okay, so if we remember, Pythagorean's theorem is a squared plus b squared equals c squared. Now, this is not provided to you on your formula sheet, so you do have to have this memorized, but hopefully you do. For the most part, everybody remembers Pythagorean's theorem. Okay, so we know that our legs are A and B, and the hypotenuse is C. Okay, so we're just going to plug in a 5 for the A, 3 for the B. Now, you could have done it either way. This could have been 3, this could have been 5. It wouldn't have made a difference. But you just have to remember that the C is the hypotenuse. Okay, so 5 squared is 25. And 3 squared is 9. Okay, so now we just have to add 25 plus 9. 25 plus 9 is 34. Okay, so do not stop here because you're not finished. We're not looking to find c squared, we're looking to find c. So in order to get rid of this exponent, we have to take the square root of both sides. So that leaves us with c over here. And then you're simply going to put this in your calculator, the square root of 34. And that gives us square root of 34. That gives us square root of 34. So you need to press your SD button to convert it into a decimal. And then you get something like 5.83095 and blah, blah, blah. Well, let's just round to one decimal place. So the answer would be 5.8. Okay, so the length of this line segment is 5.8. So we got 5.8 units. Okay, awesome. So hopefully you guys are ready to try one on your own. You try number 1B. So it's the same type of problem. Find the distance between the 2 points using Pythagorean's theorem. So go ahead and pause the video and try this problem out on your own. Do not press play until everyone has worked the problem by themselves. All right, so just like the example we just did, we're going to create a right triangle. And here's our right angle. We need to find the length of the sides. So, find the length of the sides. So we got 1, 2, 3, 4. One, 2, 3, 4, 5, 6. Okay, we're going to write down Pythagorean's theorem, a squared plus b squared equals c squared. Plug in our legs, 4 squared plus 6 squared equals c squared. Square of 4, 4 squared is 16, 6 squared is 36. Okay, 16 plus 36 gives us 52. Take the square root of both sides. C equals, and we round it to the 10th, it's 7.2. So the length of this line segment is 7.2. So our answer is 7.2 units. All right, so now it's time for you guys to try your practice. Good luck.